As someone who has taught algebra to now hundreds of students, I've seen how understanding this simple concept can make all the difference. Look at this stack of different coloured blocks. Each represents a different algebraic term. What happens when we combine or remove some of them? The result might just simplify the entire expression. And trust me, once you get this, algebra becomes a lot easier. Welcome back to the pyramids of algebra. Each pyramid reveals a unique math skill. Last time we mastered these lessons, and next we'll explore adding and subtracting algebraic expressions. In this video, I'll reveal 4 essential keys that have unlocked my students' understanding on this lesson. Stick around to find out these secrets and see how they can work in your favour too. Starting with the first key. Let's quickly revisit the shortcut of addition of the same number. What's one way I could simplify this expression? We could say 6 groups of 3 plus 4 groups of 5. We're allowed to collect the 3's because they're the same number. And the same with the 5's. This highlights the idea you can only collect groups of the same number. Remember, algebra is the mathematics when we work with numbers, but we can't see its actual value. Here we're faced with our first problem. How do you collect numbers in algebra if you can't see that they are the same? Since this example is what we want to replicate for algebraic terms, I'll leave this in the corner until we solve this problem. In algebra, we have 3 rules to help us know if unknown numbers are the same. The first is easy. We use the same variable to represent the same unknown number. For example, imagine I had 3 boxes. Each box had the exact same unknown number of chocolates in them. Since each box had the same unknown number, we can use the same letter and write B plus B plus B. Like our starting example, we can collect them, giving us 3B. Now let's imagine I then introduce 2 new mega boxes. Both have the same unknown number. However, they have more chocolates than the first 3 boxes. In other words, a different unknown number compared to the first boxes. So we need to use a different variable. Let's say M, giving us M plus M. We can collect them, making it 2M. We stop at 3B plus 2M. We can't collect them any further because they are different unknown numbers. Here's our next problem. Is x and x squared the same number? They do have the same letter, but let's imagine if x equals 2. Then x squared is x times x, which will equal 2 times 2 being 4. They aren't the same number. Therefore, the second rule, to know if an unknown number is the same, is same variable, same power. Next, let's look at this situation. Is each AB the same number? Let's prove it the same way. If A equals 2 and B equals 3. Remember, there is a hidden multiplication between the ABs. Completing each calculation, each will equal 6. They are the same number. So we can collect them equaling 3 groups of AB, which is 3AB. This gives us our final rule, the exact same product of variables. If algebraic terms ticks these 3 boxes, we call them like terms. In algebra, we can only add and subtract like terms. Now, one of the most important skills in this video is to successfully identify your like terms. Let's master this in the second key. Here you are a detective. I'll reveal 3 expressions each time you need to uncover the imposter, which is the term that is not a like term to the others. Try get 3 from 3. Here is the first expression. If you selected 5B, you are correct, since it is a different variable. Here is the second expression. If you selected 3x cubed, you are correct, since it is a different power from the rest. Here is the third expression. If you selected 6gh, you are correct, since it has a different group of variables. Now that you know how to identify the like terms, let's learn how to add and subtract algebraic expressions in the third key. Adding and subtracting algebra is as easy as adding and subtracting building blocks, with one critical rule. We can only add and subtract blocks of the same color, or in terms of algebra, like terms, which is the same unknown number. So the steps to solve are as followed. Step 1. Identify the like terms. These are the same color building blocks. Step 2. Collect each like term one at a time, and thinking of the number line can help. Let's see how it works in this example. I'll also show you what it looks like with a visual demonstration. Let's first identify our like terms. G and 3G are the same letter and the same power. We could use shapes to highlight our like terms. Then 5H and the minus 2H are the same letter, same power, so these are also like terms. Now we collect each like term at a time. Let's collect the G's first. The first term tells you where you start on the number line, so 1G. Then we're asked to add 3 groups of G. And 1 group of G plus 3 groups of G is 4 groups of G, or 4G. Now collecting the H's. We start at 5H on the number line, then we subtract 2 groups of H. And 5 groups minus 2 groups equals 3 groups of H, or 3H. So that's it, right? No, it doesn't matter how good you are at performing the skill. If you don't know the language used in your exams, you could miss out on easy marks. Let's discover the language used in the fourth key. The common language used to describe details about an algebraic expression are as followed. Here we can see we have 3 completely different objects adding or subtracting each other. We use the word term. For instance, if you want to specifically talk about the x squared, that is the first term. Moving on to the plus 4x will be the second term. And finally, the minus 2 will be the third term. Algebraic terms have pronumerals in them. Constant terms are numbers without pronumerals. In this example, the x squared and the plus 4x will be the algebraic terms, while the minus 2 will be the constant term. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.